Welcome back everybody. This is our fourth video in question bank / numerical series for class 10th chapter electricity. Till now we have covered three videos in this series and out of those two videos in one out of these three in two we have covered one exercise, and in third video we started another exercise which we are going to continue in this video. And if you have not watched our previous videos, then you can find them on our YouTube channel, and there is a playlist named class 10 physics, and there you can find out both theoretical classes and numerical and question banks for respective physics chapters. So you can check out, and if you like our work and our video, our content, then please don't forget to like this video, share this video, and subscribe to our channel. It is a zero cost way for you to support us, so please do like, share, and subscribe. Your share and subscribe makes us motivated to make such more content, so it helps a lot. So do like, share, and subscribe. With this, let's start today's video. In previous video we have completed up to question number 20, and from today we are going to start from question number 21. So let's start. So in 21, resistance is given 625 ohm and potential is given 250 volts. We have to determine the current and its power rating. So it's quite easy, we have covered such questions. So here potential is 250 volt and resistance is 625 ohm. So current is, we can find out from Ohm's law, V is equal to IR, and from here I is equal to V by R, and current value will be this. You can cut it out to 25 by 10, or answer will be 0.4 ampere. Now regarding power is voltage into current. So potential is 250, current is 4 by 10, so 100 watt is the answer for power. So this is question number 21. Let's move to 22. Determine the resistance of a coil connected to 150 volt supply. So potential is 150 volts and values of current is given. First current is 75 milliampere. So in first case current is 75 milliampere. 75 milliampere means 10 to the power minus 3 ampere. So we have to find the power. So power is VI. We just multiply 150 into 75 into 10 to the power minus 3, and you can directly find the answer. So it will be 1125 into 10 to the power minus 2, or you can write it 11.25 watt. When current is 300 microampere, then you can put here current equal to 300 microampere, and answer will be, you will get different power, because here now second current is 300 microampere, and microampere means 300 into 10 to the power minus 6 ampere. And now you can use the same formula for power, multiply potential by this new current, and you will get value of power. So moving to question number 23rd. We have to find the resistance of an electric fire where current is given 12 ampere and potential is given 240. So and power is also required and energy used in 20 hours. So here I is 12 ampere, potential is 240 volts. So using Ohm's law, V is equal to IR, we get R is equal to V by I. V is 240 by 12, we get 20 ohm. Now we have to find the power rating. So power is VI, V is 240, current is 12, so we will get it as 240 plus 48, 0, so it will be 8820 watt. You can check the multiply, and you can also write is 2.88 kilowatt. Now energy used in 20 hours. So I have already said to you, already explained in theory class also, that when we get this power for daily purpose appliances, then it always given as kilowatt per hour. So 1 hour it consumes 2.88 kilowatt, and in 20 hours it will consume 2.88 into 20. So this will be 6750 kilowatt. 5.57.6 kilowatt will be your answer. Moving to question number 24. Determine the power dissipated when current is 10 milliampere and resistance is 8 kilo ohm. So I is 10 milliampere and resistance is 8 kilo ohm, means 10 to the power 3. So power is I square R. So we can calculate it simply. I square will be, this is equal to 10 to the power minus 2 ampere. So squaring this will get 10 to the power minus 4 into R. So we will get 8 into 10 to the power minus 1, or 0.8 watts. So this is question number 24. Moving to question number 25. 85.5 joule of energy is converted into heat in 9 seconds. What is power? So here energy is 85.5 joule, time is 9 seconds. So power formula for power is, in terms of energy, is energy by time. Power is rate of doing work with respect to time. So here is energy by time. So answer will be 85.5. This will give you 9.5 watt is your answer, and unit of power is watt, so answer will be 9.5 watts. Moving to question number 26. Value of current is 4 ampere, power is 10 watt. What is the potential difference? So power is 10 watt, current is 4 ampere. We have to find out potential difference. So power is V into I. We know power is 10. V we will calculate. I is 4. So V is 10 by 4, or 2.25 volts is the answer for power. Moving to next question, 27. Find the power dissipated when 5 milliampere current flow through a resistance of 20 kilo ohm. So we know power is I square R. Current is 5 milliampere, so 5 into 10 to the power minus 3. 5 into 10 to the power minus 3. This is current square into R, 20 kilo ohm, 20 into 10 to the power 3. This will get it, and 25 into 250 into 0, 500 into 10 to the power minus 3, or it is 0.5 watt. Now going to second option, second part. Voltage is 400 watt and resistance is 120 kilowatt. So in this regard, we have formula for power is V square by R. We have different formulas for power. We can use whichever applicable. So 400 into 400 by R is 120 kilowatts. So it's 10 is power 3. So this 10 is power 3 and 0. So total 10 is power 4 means 4 zeros. So these all 4 zeros will get cancelled, and this will be 4 by 3 watt or 1.33 watt. Now in the third part, C, voltage applied to a resistor 10 kilovolt. Voltage is given and current is given. So power is simply V into I. 10 kilovolts, so 10 into power 3. Current is 4 milliampere, 4 into 10 to the power minus 3. So it is 40 watt. These will get cancelled out. So with this, moving to question number 28. Battery of EMF. What is EMF? EMF stand for electromotive force. EMF is short form of electromotive force, and it is also known as electric potential. Okay, so potential is given 50 volt, current is given 2 ampere, and time is given 5 minutes. So we have to find the energy. So we know energy is power into time. So power is equal to voltage into current, and time is as it is. So voltage is, your potential is 15, current is 2, time is 5 minutes. We have to convert into seconds. So 5 minutes is equal to 300 seconds. So we get 30 into 300, it will be 9000 joules, and it is heat. Heat and energy's unit is joule, and power energy is watt, and watt is joule per second. Power's unit is joule per second, and time's unit is second. So you can get second get cancelled, you will be left with only joule. So unit of heat is joule. With this, question number 28 is completed. We will move to next question. So let us start question number 29. In 29, it is mentioned that there are 3 2 kilowatt fires that are used average 20 hours each, 25 hours each. So they will be used in a week, because in a day you have only 24 hours, so you cannot use it 25 hours in a day. So this uses all for 1 week. So we have 25 hour each of 2 kilowatt fire, and 8, and it is 3 fire, and 100 watt 35 hours each of 100 watt light bulb, and these we have total 8. So we have to find out the total cost. With cost rate is 7 paise per kilowatt or per unit. So first we will do this. For one fire it's 2 kilowatt, for 3 fires it will be 2 into 3, 6 kilowatt, and it is per hour. So for fire we will be using 6 kilowatt energy per hour, and we have to get it for 25 hours. So our total uses will be 25 kilowatt into 25, and this will be 150 kilowatts total energy uses for fires for a week. Now going similarly with four bulbs, we have 8 bulbs, and each bulb uses 100 watt. So for 8 bulbs we will be using 800 watts per hour, and we will be using bulbs for 35 hours. So 800 watt into 35, we will get something like 240 plus 40, 280,000 or 28 kilowatt in total for bulbs, 150 kilowatt for fire and 28 kilowatt for bulbs. So in total we are using, our total power consumption is 150 plus 28 is equal to 178 kilowatt. Now for 1 kilowatt charges are 7 by 100 rupees. 7 paisa is the charges for 1 kilowatt. So for 170 kilowatt, 178 kilowatt, it will be 7 by 100 into 178, and you can multiply to get the answer. It will be 1246 by 100 or rupees 12 and 46 paisa is the cost that it will occur at this rate of 7 paise per unit. So moving to question number 30. Calculate the power dissipated by element of electric fire. Resistance is given, current is given. So resistance is 30 ohm, current is 10 ampere. So power is I square R. So 10 into 10 into 30, we will get, this will be 3000 watt or 3 kilowatt, and it is per hour. Okay, so we are using it for 30 hours. So for 1 hour it is 3 kilowatt, for 30 hours it will be 3 into 30, 90 kilowatt, and costs are, for 1 kilowatt it is 7.2 paisa. So 1 kilowatt cost is 7.2 paisa. So for 90 kilowatt it will be 7.2 divide 100 into 90, we will get 1864 by 100 or rupees 6 and 48 paisa is the answer for question number 30. Now we are going to solve question number 31. So in question number 31, television set is given rating of 120 watt. It is rating of watt, so it is power 120 watt. And electric lawn mower and power rating of 1 kilowatt. So this is P1, and we have another rating of 1 kilowatt, so 1000 watt. Now potential is given 240 watt. Both are connected to same potential. We have to choose suitable fuses for them. So for fuses we have three options: 3 ampere, 5 ampere and 10 ampere. This can be done. First we have to find out respective current for these powers, and then we can choose a fuse which is just little above that current rating. That will be the suitable fuse. So for first, we know that power is VI and power is 120, voltage is 240 and I as it is, so I will be 120 by 240 or 0.5 ampere, and your current is 0.5, but you have fuses for 3 ampere, 5 ampere and 10 ampere. So you cannot use any of these mentioned fuses. So from these values of fuses, we have 3 ampere, 5 ampere and 10 ampere. None of the fuse is properly applicable to this instrument. A fuse having around 0.5 or suppose 1 ampere rating should be suitable for this type of instrument. So now going to second instrument where power is 1000 watt. So current will be 1000 by 240, that is potential, because current is power by potential. So this will be approximately greater than 4 point something, so 4.2 or 4.3. And here 5 ampere switch will be fuse will be a good option to choose, because if you choose 3 ampere fuse, it will not allow instrument to work at its mentioned power. And if you choose a higher power fuse, then it can allow instrument to get damaged when high potential or high current start flowing. So for second we have a option here. For first one we don't have any reliable option here to choose from. So with this, question number 31 is complete. Going to question number 32. We have a heater and its power is rated as 4 kilowatt. So power is 4 kilowatt or 4000 watts and potential is 220 volts. We have to find the current, resistance, energy consumed in 2 hours and cost. So first of all, we will find current. So current is power by potential, because power is volt in potential into current. So 4000 into 220, and it will be 200 by 11, and that will be 17.2 amperes. Resistance we can find out as power is V square by R. So resistance is V square by P, and it is 220 into 220 by 4000. So 11 by 20 or 11 by 10, 1 to 1 by 10 or 12.1 ohm is the value of resistance, and value of current is 17.2 ampere. Now we have to find out the energy consumed in 2 hours. So its rating is given 4 kilowatt. It is using 4 kilowatt in 1 hour. So in 2 hour it will be using 4 into 2 equal to 8 kilowatt. It will be using in 2 hours. And cost, if price for means if cost for 1 kilowatt is 4 rupees and 60 paise, then for 2 hours it will be 8 into 4.6, and it will be 32 plus 4.8, so 36.8 rupees. It will be the total cost for 8 hours. Now moving to question number 33. So in 33 it is mentioned a radius set of 60 watt run for 50 hours. How much electrical energy it consumes? So we have to find out energy, and energy unit is in joule. So it is given 60 watt, and 60 watt means 60 joule per second, and it is for per hour. Normally for instrument it is given for per hour. So 60 joule per hour. Now for 50 hours it will be 60 into 50 or it will be 3000 joules. And if it is given as joule second, then the answer will be 60 into 50, and it is joule second, then we have to multiply the amount of seconds, and this will be the answer depending upon the type of question. It is given in kilowatt hour or in watt hour or watt second, the answer will change. So moving to question number 34. A current of 4 ampere flows through a 12 volt and headlight bulb for 10 minutes. How much energy transfer occurs? So current is 4 ampere and potential is 12 volts. So power is 12 into 4, 48, and it is joule per second. And time is given 10 minutes. So 48 into 10 into 60. This will be the answer. And it is 240 plus 48, 00. So 28800 joules will be the answer. Moving to next question, question number 35. For 30 minutes, calculate the energy transferred by 5 ampere current flowing through resistance of 2 ohm. This will be 2 ohm. So power is I square R, and I is 5. So 5 into 5, and R is 2. So this will be 25 into 2, 50 joule per second of 50 watt. And we have to find out for 30 minutes. So answer will be 50 into 30 into 60. And it comes out to be 90,000 joules is our answer. So with this, question number 35 is complete. Let's move to 36. So bulb is rated at 200 volt and 1000 watt, 100 watt. So potential is 200 watts and power is 100 watt. The resistance we have to find out. So resistance we can find out using this formula, P is equal to V square by R. Using this, resistance is V square by P, and 200 into 200 by 100. So resistance is 400 ohm. 5 such bulbs burn. Now there are 5 such bulbs and each run for 5 hours. So one bulb running for 1 hour uses 100 watt. So 5 bulbs running for 1 hour will be using 500 watts, and 5 bulbs running for 5 hours each will be using 500 into 5, 2.5 kilowatt or 2500 watts. So it will be 2.5 kilowatt. Now cost for 1 kilowatt is 4.6. So total cost will be 4.6 into 2.5, and from this we will get 11 rupees and 50 paise is the answer. With this, question number 36 is complete. Moving to question number 37. A refrigerator having a power rating of 350 operates for 10 hours. So power is 350 and time is 10 hours. So total power consumed will be 350 into 10 or 3500 watt or 3.5 kilowatt. Now calculate the cost if this refrigerator run for 30 days. Now it was running 10 hours a day. So this was consumption for one day. Now for 30 days it will be 3.5 into 30 and answer will be 1050.0 or 1105 kilowatt. Now we have to find the cost at 3.4 rupees per kilowatt hour. So our total uses are 105 kilowatt hours. So cost will be 105 into 3.4 and the answer will be 357 rupees. Moving to question number 38. What will be the current drawn by an electric bulb of 40 watt when it is converted to a source of 220 connected? It is converted written here, it should be connected. So power is 40 watt, potential is 220 volts. So current will be power by potential. So 40 by 220, it will be 2 by 11 or 0.1.8 ampere will be the answer. Moving to 39. So in 39, bulb is rated at potential is 220, power is 100, and it is operated at 110. Find the power consumed. So here you can see that potential is reduced. So how we will find the power? First we will find the resistance. Then we will use that resistance to solve for this new potential. So our initial potential is 220 volt and power is 100 watt. From this we will find the resistance. How? Power is V square by R, because once the bulb is made, its element has been already selected, its filament is already been selected, so its resistance will not change. Current and potential can change depending upon what we apply, but resistance cannot change because it is a property of material. So we will calculate resistance. Resistance will be V square by P, 220 into 220 by 100, and it will give us 484 ohm. So resistance is 484 ohm. Now new potential is 100 volt. Now we will find the power again using formula V square by R. New potential is 110. So square of it, and potential is 484, and it was 22 into 22 because both zeros can get cancelled. Here we will be writing 22 into 22. So 10, 5, and this will be again 5. So power is 25 watts. So here you can say that when potential is dropped by half, power drops by 4 times, because power has square here. So if you divide power by 2, potential by 2, power gets divided by 4. Now moving to question number 40. An electric heater draws a current of 10 ampere from a 220 volt supply. So current is 10 ampere, potential is 220 volt. Cost we have to find out for running every day for 5 hours. So power is potential into current into potential, that will be 2200 watt or 2.2 kilowatt for 1 hour. It is running 5 hours a day. So for one day, total uses will be 11 kilowatt. Now we have to using we will be using it for 30 days. So 11 kilowatt into 30, it will be 330 kilowatts per hour for a month. And for 1 unit we have 5 rupees and 20 paise, and for 330 unit the cost will be this. So we can calculate 330 multiply 5.2. The answer is 171.6 170 716 rupees. 1716 rupees will be the answer. So with this, let's start question number 41. So in question number 41, in house 260-watt electric bulb are lighting for 4 hours and 300-watt bulb for 5 hours every day. So 260-watt bulb for 4 hours and 300-watt bulb for 5 hours. We have to calculate the energy consumed in 30 days. So 260-watt bulb we use 120 watt for 1 hour, and for 4 hour they will be using 480 watt. 300-watt bulb will use 300 watt for 1 hour, and for 5 hours they will be using 1500 watts. So total uses for 1 day will be 1980 watts. Now we have to find out consumption for 30 days. So we just simply multiply this with 30 and we will get answer for total watt uses for 30 days, and it will be 59400 or 59.4 kilowatt of energy will be used. Okay, kilowatt hour energy will be used. Going to question number 42. An electric motor takes 5 ampere current. Current is given, potential is given. So we have to calculate the power and energy consumed in 2 hours. So power will be V potential into current. This will give us 1100 watt, and this will be 1100 watt per hour, and for 2 hours it will be 1100 into 2, 2200 watt or 2.2 kilowatt hour of energy will be used in this question 42. With this, let's move to question number 43. So here we can see on question number 43, there is an electric iron which consumes 840 watt when heating at maximum rate and 360. We have done similar type of question in our previous video. You can check out there. We have to find out maximum and minimum current for this iron, and that we have already done, so you can check it out. Moving to question number 44. An electric refrigerator rated 400 watt operate at 8 hours per day. So 400 watt for 1 hour, for 8 hours it will be using 3200 watt per hour of energy. Now it is operated at for 30 days and this is equal to 3.2 kilowatt hour. For 30 days, kilowatt per hour. For 30 days it will be 3.2 into 30 or 96 kilowatt per hour of energy will be used. Now we have to find total cost at the rate of 3 per kilowatt hour. So total cost will be 96 into 3, 270 plus 18. So it will be 288 rupees will be the answer for 44. Moving to last question for today, that question number 45. So in question number 45, a motor is there which take 5 ampere current from this potential, determine the power and energy consumed in 2 hours. It's a simple question. So power will be 220 into 5. I think we have already done this type of question. 1100 watt. And energy consumed in 2 hours. This is the energy consumed in 1 hour. So in 2 hours, this will be 2200 watt or 2.2 kilowatt is the final answer. So with this, we have completed up to question number 45, and I am expecting to complete this exercise in our next video. If you have any doubts, any questions, then you can ask in comment section. And if you like our work, if you like this video, then please like, share, and subscribe, because your share and subscribe help us a lot. It motivates us to make such content in a more profound way. So please do like, share, and subscribe. Keep on watching, keep on studying. You can also check out our other videos on our YouTube channel. We have class 9th physics and class 10th physics videos are there with the theory and numericals in detail for physics. So with this, I take leave from now, and we will meet in next video.